but in the field of organic chemistry, which will enable us in enhancing our understanding and give us a spark in organic chemistry. Next, I would like to welcome our Association Secretary, Alina Ebi Abraham, for the welcome speech.
Good morning, everyone. We're gathered here to attend a webinar on the brief history of Nobel Prize in Organic Chemistry. The keynote for the day is to create an interest in the field of organic chemistry, which many of us may find rather difficult, but is indeed a fascinating area. On behalf of the Postgraduate Department of Chemistry, St. Mary's College, Manargat, it is a moment of extreme pleasure to welcome the guests who are present to attend this webinar. We cannot begin without offering regards to Dr. Shibi Susan Kuriakos, the head of Chemistry Department, Dr. Marina Philip, our College IQSC coordinator, and Tony Sir, Assistant Professor of our department, for coordinating today's event. Next up, I'm profoundly delighted to welcome Dr. Ranjeesh KC. Ranjeesh Sir has a PhD in the field of organic chemistry. He works at the National Chemical Laboratory, Maharashtra, in the Organic Chemistry Division. He has about 11 publications and several patents in his name. Thank you so much, sir, for accepting our invitation for this webinar. Finally, I would like to welcome all the professors, staff members, students, and the participants present to make this event worthwhile. I hope this conference enlightens us all.
Thank you, Alina. Next, I would invite HOD of Chemistry Department, Dr. Shibi Susan Kuriakos, for the presidential address.
Thank you, Elsa. ഇന്നത്തെ നമ്മളുടെ വിശിഷ്ടാതിഥി ഡോക്ടർ രഞ്ജീഷ് KC, ഇവിടെ സന്നിഹിതരായിരിക്കുന്ന മറ്റ് അധ്യാപക ശ്രേഷ്ഠരെ, എൻ്റെ പ്രിയപ്പെട്ട വിദ്യാർത്ഥിനികളെ, വിദ്യാഭ്യാസ കാലയളവ് ഏതൊരാളുടെയും രൂപീകരണത്തിന്റെ കാലയളവാണ്. നാം എങ്ങനെയൊക്കെ ആയിത്തീരണം, ആരൊക്കെ ആയിത്തീരണം എന്ന് നിർണ്ണയിക്കപ്പെടുന്നത് ഈ സമയത്താണ്. പ്രോത്സാഹനജനകമായ കാര്യങ്ങൾ നമ്മുടെ മനസ്സിലേക്ക് കടത്തിവിട്ടാൽ അത് നമ്മളുടെ ഭാവി ജീവിതത്തിന് വളരെയധികം പ്രയോജനം ചെയ്യുന്നതായി നമുക്കറിയാം. അത്തരം ഒരു വെബിനാറാണ് നമ്മൾ ഇന്നിവിടെ സംഘടിപ്പിച്ചിരിക്കുന്നത്. തൊട്ട് മുൻപിലത്തെ വർഷം മാനവരാശിക്ക് ഏറ്റവും പ്രയോജനകരമായ കാര്യങ്ങൾ, ഏറ്റവും പ്രയോജനകരമായ പ്രവർത്തനങ്ങൾ ചെയ്യുന്ന അല്ലെങ്കിൽ അതിനുള്ള കണ്ടുപിടുത്തങ്ങൾ നടത്തിയ സയന്റിസ്റ്റുകൾക്ക് നൽകപ്പെടുന്ന നൊബേൽ പ്രൈസ് ആദ്യമായി കൊടുക്കപ്പെട്ടത് 1901 ഡിസംബർ 10 ആയിരുന്നു. ആ വിഖ്യാത ശാസ്ത്രജ്ഞന്റെ 5ാം ചരമവാർഷിക ദിനമായിരുന്നു അത്. 1901 വാൻ ഹോഫ് മുതൽ 2020 ജെനിഫർ ഡൂഡ്ന, ഇമ്മാനുവൽ ഷാപ്പിൻഡിയർ വരെ ആ ലിസ്റ്റ് നീളുകയാണ്. എ ബ്രീഫ് ഹിസ്റ്ററി ഓഫ് നൊബേൽ പ്രൈസ് ഇൻ ഓർഗാനിക് കെമിസ്ട്രി എന്ന വിഷയത്തെ ആസ്പദമാക്കി നടത്തുന്ന ഈ വെബിനാർ ഈ വിഷയത്തിൽ നിങ്ങൾക്ക് ഏവർക്കും കൂടുതൽ വിജ്ഞാനം പകർന്നു തരും എന്ന് ഞാൻ പ്രത്യാശിക്കുകയാണ്. അതിനായി നമുക്ക് ഏവർക്കും കാത്തിരിക്കാം, കാതോർത്തിരിക്കാം. ഈ വെബിനാർ സംഘടിപ്പിച്ച നിങ്ങൾക്ക് ഏവർക്കും എൻ്റെ എല്ലാവിധ ആശംസകളും നേരുന്നു. നമുക്ക് വെബിനാറിന് വേണ്ടി കാത്തിരിക്കാം. നന്ദി, നമസ്കാരം.
Thank you, Shibi Miss. I am pleased to introduce our chief guest, Dr. Ranjeesh KC, sir. He has done his research and obtained MPhil and PhD in the field of organic chemistry. He has been honored with many awards such as Best Research Scholar, Krishnan Award, Best Oral Presentation Award, and possesses many publications by his name. I gladly welcome Dr. Ranjeesh sir for the webinar.
രഞ്ജിഷെ കേൾക്കത്തില്ലേ?
Hello.
കേൾക്കാം.
Okay. Screen is visible?
Yes, you are visible.
Okay. So, thank you for the kind introduction. and very elaborate introduction on the Nobel Prize. So I don't need to introduce again the importance of Nobel Prize and the background of Nobel Prize. We will directly go to the topic, brief history of Nobel Prize in organic chemistry. So this will enable us to understand the importance of organic chemistry and the benchmark discoveries in the field of organic chemistry. So first, I am introducing Friedrich Wöhler. So after seeing his lifetime, you might be wonder why I took Wöhler. He is not a recipient of Nobel Prize, but Wöhler enormously contributed in the field of organic chemistry. Due to his lifespan, he couldn't able to obtain Nobel Prize because Nobel Prize is established in 1895 by the will of Alfred Nobel. Later onwards, in 5 different areas as described, the Nobel Prize is awarded. So the Wöhler is seminal contribution to the organic chemistry, in particular Wöhler synthesis of urea. So before the time of Wöhler, it is believed that the organic compounds could be produced only by the living organism. That theory is known as vital force theory, or life force is required to produce organic molecules. So Wohler prepared the urea by from a inorganic substance, ammonia cyanate, on heating it to produce urea. And Wohler enormously contributed in the concept of functional group of organic compounds. We know that the functional group of organic compounds will considerably influence the properties and both the chemical and the physical properties of that organic compound. So, Wohler widely contributed in the area of organic chemistry, but he couldn't able to receive a Nobel Prize. So, but his contribution we cannot neglect. So, the first organic chemist who won Nobel Prize is Emil Fischer. Just after Van Hoff, Van Hoff awarded Nobel Prize in 1901. That is the first Nobel Prize. The second Nobel Prize is awarded in 1902 by to the Emil Fischer. So he contributed in the areas of purine-based compounds and sugars, generally carbohydrate. These molecules are very difficult to purify and characterize, but he took this challenge on reaction with the phenylhydrazine. This kind of compounds are start to extract, and he evaluated the structure in that period itself. So these are known as the energy molecules for animals. Human beings also consuming sugars for in the
in the
part of
part of the
diet.
diet.
Hello, it is echoing.
ഓക്കെ മ്യൂട്ട് ആക്കിയിട്ടുണ്ട്.
Okay. So there are two type of glucose. He find out the structure D-glucose and the L-glucose, and we might be well familiar with the Fischer projection formula used for the uh, uh, carbohydrate structure elucidation, and a caffeine kind of molecule also isolated by Emil Fischer. So the entire contribution of Emil Fischer in the field of sugar and purine-based groups of substances and bringing chemistry to biology, he received the Nobel Prize in 1902. So that are the contributions of Emil Fischer. Next person who awarded the Nobel Prize in Organic Chemistry is Adolf von Bayer in 1905. He widely worked with the dyes molecule. So this is we can consider his contribution is the birth of dyeing. The dye industry is widely used in textiles and printing. So he extracted various dyes from the plants. So indigo dye is one of the very famous dye. Now also we are using in textile industry. The jeans materials are colored with this blue color. It is from indigo dye. So another contribution is the Thalene class of dyes he widely prepared in his laboratory. So both its contributions, not only the isolation of this kind of dyes in natural compounds, he assigned the synthesis of these compounds very easily from petrochemicals. So that lead to the area of dye industry very widely and enormous development in the area. And now we know that the all the 7 colors or more than that colors are available uh, for dye stuffs and the printing industry. So which start from the origin is start from the Adolf von Bayer contribution. So it is recognized in 1905. He awarded the Nobel Prize. The next Nobel Prize in organic chemistry is coming in the year of 1912. So it is awarded to two persons, Victor Grignard and Sabatier. So Victor Grignard contribution you might be already knowing. He prepared the alkyl magnesium halide RMGX reagent so that can attack to the various substrate and make n number of chemical transformations and result the various product. So it ultimately result the creating carbon connections. So it widely used in various organic transformations, this organomagnesium reagent and later organolithium reagents also used for the same purpose. So we can understand the various transformations are possible when the Grignard is retiring. That time around 6,000 publications are available in the literature citing the Grignard reagent. So that itself indicate the uh, volume of contribution made by the Grignard reagent in the organic chemistry. So in the 1912, another chemist who awarded the Nobel Prize is Paul Sabatier. He is a French chemist. So along with the Grignard, he is the co-recipient of the Nobel Prize. He particularly worked in the hydrogenation and dehydrogenation reactions. Basically, he worked with a nickel-based catalysts. So he find the industrial way to convert liquid fat to solid fat by hydrogenation reaction. So his scientific contributions are very much useful in both academic and industrial areas. So he awarded for his contribution Nobel Prize in 1912. So the next person, next scientist who awarded the Nobel Prize is Sir Robert Robinson. So we know that the master of chemical synthesis is nature. Up to nature, nobody synthesized the complicated structures. So first time in the history of organic chemistry, Sir Robert Robinson take a challenge to synthesize the complicated natural products, notably alkaloids, and flavonoids, morphine and strychnine kind of organic molecules, which are chirality and structurally very challenging molecules. Total synthesis he could able to achieve. And Robinson, another important contribution is a name reaction called Robinson annulation. It is a Michael addition followed by condensation reaction, giving the cyclic structure. You might be learned in your as a part of your curriculum in MSc syllabus. So altogether, his contributions are recognized in 1947 in the form of Nature's assembly instructions he find out. So he received the Nobel Prize. Next Nobel Prize in organic chemistry is coming in 1950 for Diels and Alder. So Diels student is Alder. Both are in German chemists. So they find out a interesting reaction called Diels Alder reaction. So Diels Alder reaction is the reaction between a diene. Two double bonds are separated by a single bond, and a dienophile, a double bond in conjugation with a electron withdrawing group. So the cyclic shift of electron is happening, and a cyclic structure is resulting with a new 2 sigma bond formation and one pi bond formation, and a six-membered cyclic structure is obtained. This kind of six-membered cyclic structure could not be arrived by any other reaction, and the nature of this reaction is highly stereospecific in nature. So if the dienophile is cis in nature, that stereochemistry will be reproduced in the product. If it is trans in nature, that same stereochemistry will be reproduced in the product. So the stereospecificity of this reaction enabled to prepare various natural products synthesis. So this reaction is widely used from the drug synthesis to plastic synthesis. It is widely used. So a well-deserved Nobel Prize is given to the closing ring in circle in 1950 Nobel Prize by Diels and Alder. And the next Nobel Prize is awarded to Robert Burns Woodward. So Robert Burns Woodward is very complicated natural products synthesis he done, and outstanding achievement he achievements in the art of organic chemistry he done. So very complicated natural products he could prepare in the laboratory. That time even the NMR is just evolving. So that time very complicated structure he could able to prepare. Another major project he carried out is vitamin B12 synthesis. That synthesis, the structure we can, once we observe this structure, we will understand how much complicated this structure. And that team is a big team, and each part of this molecule is distributed to the various students, and finally it assembled together and formed the vitamin B12 molecule. So similarly, the chlorophyll system, the photosynthetic unit of the uh, uh, plants are synthesized by Robert Woodward and co-workers. So his outstanding achievement in the art of organic chemistry, he received the Nobel Prize. There is a saying that uh, just after nature the Robert Woodward synthesis is done. So the master of organic synthesis is nature. Just after that, that complicated synthesis strategy is adopted by Robert Burns Woodward. So the next Nobel Prize is in 1979, that is for the chemical construction tools. It is awarded to two persons, Herbert H.C. Brown as well as George Whiting. So H.C. Brown is widely work on the borane-based chemistry. So one of the name reaction known as hydroboration oxidation, and one of the reducing agent widely used in laboratory as well as in industries chemical practices is sodium borohydrate, that is also introduced by H.C. Brown. So hydroboration oxidation is the name reaction. So syn addition of borane is happening over a double bond and followed by oxidation reaction is occurring. And after oxidation reaction, we are end up with an alcohol. So this alcohol addition, hydroxyl group introduction is following a anti-Markovnikov rule. Markovnikov rule, according to Markovnikov rule, the nucleophile addition happen to the most substituted site, not to the least substituted site. But due to hydroboration oxidation reaction, this nucleophile hydroxyl group introduction is happening to the least substituted site. So that is all about the hydroboration oxidation reaction. And the driving force for this reaction is this particular molecule formation. The boric acid formation is the driving force for our desired product. Even though it is a side product, the driving force for this formation is the boric acid formation. That fuel is boric acid formation. Next, the co-recipient of the Nobel Prize is George Whiting. He widely worked with the organophosphorus compounds, and a famous name reaction he established is Whiting reaction. So we can look at how we can prepare a Whiting elite. So it is a simple SN2 reaction. So here carbon center is positively charged. So closer to a bromide. So substitution is happening and a phosphonium ion is resulting. Then this CH bond electron density will be withdrawn by this phosphonium ion. So it is possible to abstract with a strong base like a butyllithium or sodium hydride. Then a carbanion is generating. See here carbon is the positive center and now the carbon center become negatively charged. So a reversal of polarity is happen here. Then it can resonate in the elite structure and this elite is very spontaneously reacting with carbonyl compounds and it forms a betaine intermediate four membered cyclic structure and a phosphorus oxygen double bond is a very strong bond in organic chemistry around 500 kilojoule per mole range that energy is coming. So phosphorus oxygen double bond formation is the fuel for this olefin formation. So the cyclic shift of electron is happening under phosphorus oxygen double bond formation. Phosphorus oxide will be formed and that that is the driving force for this reaction and it ultimately result the olefin. So this reaction is a stereo selective reaction. Stereoselective reaction means there are two possibilities. One stereoisomer will be major. That is what the meaning of stereoselectivity. So when we are taking a unstable elite means the carbanion could not be resonance stabilized by any electron withdrawing group. Instead of that, electron releasing group will be attached. So that elite is called a unstable elite. So unstable elite directly attack and it will form the betaine intermediate and directly it will end up into major Z alkene or cis alkene. In the for the preparation of trans alkene, a electron withdrawing group attached carbanion elite will be used. So here we have an ester group to withdraw this electron density. So this elite will be relatively stable elite. So it will rearrange into conformationally more stable structure, that is trans structure. So it will ultimately result to a E alkene. So that is all about the stereoselectivity of Witting reaction. Witting reaction is stereoselective in nature. If we take unstable elite, we will end up with a major Z alkene or cis alkene, or if we take stable elite, it will end up major amount of E alkene or trans alkene. Next Nobel Prize is awarded in 1990. E.J. Corey is awarded in the field of organic chemistry. He is the American organic chemist. So he developed numerous reagents under synthetic methodologies and a total synthesis he carried out for many molecules. The major contribution is retrosynthetic analysis. He made a rational analysis technique known as retrosynthesis. I will explain what is retrosynthesis from a example of prostaglandin synthesis. So this is the final target molecule. So we have to break the bonds and we have to find from which it can be prepared. That concept is known as retrosynthetic analysis. So there is a cis olefin. So we have to take a unstable Witting elite, and there is a trans olefin. So it can be a Horner-Wadsworth Emmons reaction. So similarly, if these three react together, it will form the target molecule. And this particular molecule can be prepared from a iodolactonization reaction, and that substrate can be prepared from this molecule, and this molecule can be arrived from a Bayer-Villiger oxidation reaction of this substrate, and this substrate can be prepared from Diels Alder reaction, and this Diels Alder product can be arrived from commercially available these two compounds. So this is the strategy. A complicated chemical structure will break down into commercially available substrate. Then forward synthesis is easily possible, and this rational analysis will be helpful to save the chemicals and man efforts. So back to future is the name I given for his contribution, and his retrosynthetic analysis concept he described in the book named The Logic of Chemical Synthesis. So all together, and we know that the Corey introduce lot of synthetic reagents and methodologies. We might be familiar with the Curie-Tchaikovsky epoxidation and Curie-Fuchs reaction. Many Curie reactions are discovered by E.J. Curie. He is one of the greatest living chemists in the present time. So he is still alive and active in the field of organic synthesis. And another Nobel Prize in organic chemistry is given in the year of 2001 for Noiri Roichi and K. Barry Sharpless and William S. Nobels. So all three are co-recipients for this Nobel Prize. Altogether, what they done is the preparation of first chiral catalysts. So chirality, we know that it is the signature of nature. Nature, all bioactive molecules are in the chiral form. Not only chiral form, it is in the particular chiral form. Either it will be R or S form. So enantioselectively preparing a particular enantiomer is challenging. Normally, it will form a racemic mixture, equal amount of both the enantiomers in equal amount. So it is very challenging to prepare a particular enantiomer with a higher selectivity. So for that, certain catalysts are prepared. Transition metal catalysts are involved in these transformations. Asymmetric transfer hydrogenation or asymmetric hydrogenation reactions by Noiri and Novels. And Nobel's particular contribution to the L-DOPA drug is synthesized by his catalysis. So industrially, L-DOPA drugs are synthesized by Nobel's chiral catalyst. So that is used for the Parkinson's disease drug. And the Sharpless contribution is for the allylic alcohols epoxidation. Depending upon the chiral media, the oxygen insertion will happen. If we take minus diethyl tartarate, it will be psi phase attack will take place. And if it is plus diethyl tartarate, rephase attack will take place. So Sharpless asymmetric epoxidation is very well known name reaction. So Sharpless also awarded co-recipient of this Nobel Prize in 2001. So helping hand for the synthesis of enantiomerically pure compounds can be achieved by these catalysts. So that is what the importance of this contribution. In order to clearly understand that importance of that contribution, I am discussing here a tragedy of thalidomide drug. So the thalidomide drug is commercially sold in 1957 in West Germany. First released thalidomide drug is promoted for the morning sickness normally observed in pregnant women. So the total embryos affected by the use during the pregnancy is estimated 10,000 embryos, and of which about 40 percentage is died around the time of birth, and those who survived had limb, eye, urinary tract, or heart problems. So some of the kids who taken thalidomide in the pregnancy time, they survived with a handicapped way. So birth defects are caused in the thalidomide led to the development of greater drug regulation and monitoring in many countries. Actually, in the thalidomide drug, R form is bioactive and that is acting as a drug for the morning sickness, but the S form is making this birth defects. So now you might be convinced the importance of the contribution by Noiri Roji under Sharpless and William novels. They find the way how to prepare enantiomerically pure organic compounds. So they recognized by Nobel Prize in 2001. And another Nobel Prize is very recent one is 2010 Nobel Prize. You might be well familiar with these names. Heck, Richard F. Heck and Negishi Ichi and Suzuki Akira. So they find out the way for the carbon-carbon bond forming reaction. Carbon-carbon bond forming reactions are very important reaction. Similarly, carbon heteroatom bond forming reactions like a CN bond forming reaction and a CO bond forming reactions also very much important. So the Heck coupling reaction is with a palladium zero catalyst base. It will couple the organohalogen compound with a olefin. So it will result the substituted olefin compound very easily with a very good yield. So it is known as Heck coupling reaction. And another is organo-zinc reagent with organohalide compound, palladium catalyst, carbon-carbon bond formation coupling will take place and result a carbon-carbon sigma bond. Similarly, organohalo compounds with boron, organoborane reagents in presence of palladium or nickel catalyst, carbon-carbon sigma bond formation is taking place. This is discovered by Suzuki and a single transmethylating agent used reaction is discovered by Negishi and Heck coupling is reported by Richard F. Heck. So now this is not an end. More organic chemists will get the Nobel Prize and many interdisciplinary areas also awarded the Nobel Prize in organic chemistry like supramolecular chemistry and Merrifield or peptide synthesis widely used in the peptide chemistry. So the supramolecular chemistry recent Nobel Prize also again Nobel Prize gone to the in the recent time. So because organic chemistry is a central part of chemistry and polymer chemistry also Ziegler-Natta catalysis got the Nobel Prize. So organic chemistry is a central part of the chemistry. So it is used for the material science and various biology and various other fields. So that interdisciplinary Nobel Prize I didn't discuss here. Now we can look at the language of organic chemistry. So this is specially for the MSc students or BSc students whoever just starting the organic chemistry learning. So normally organic chemistry reaction mechanisms are we will represent by arrows. So the arrow tail will be from electron rich and arrowhead will be pointing towards the electron deficient. So in that manner, we are writing the organic reaction mechanisms and the bond cleavage can be half arrows. If we represent, it will be homolytic bond cleavage and it will result radical and heterolytic bond cleavage we will represent by full arrows, and carbocations or carbanions it will result. See here, carbocation is forming, and here carbanion is forming. I put here a question. CH bond cleavage is unusual in organic chemistry, whether it is true or false. So the CH bond is very strong bond. We cannot cleave a CH bond that much easily because the bond energy is bond length is 1.09, and the bond energy is 413 kilojoule per mole. So it is stronger than that of C carbon-carbon single bond. So here I brought the boron-oxygen bond. See the bond energy. It is very high bond energy, 536 kilojoule per mole. So that is the driving force for the hydroboration oxidation reaction and the boric acid formation. And the phosphorus oxygen double bond, bond length is 1.50, and the bond energy in the kilojoule per mole is 544 kilojoule per mole. So that is also very stable bond, strong bond. So that is the reason why Witting reaction is happening. So what I want to conclude is CH bond cleavage is not usual. It is only happen when a electron withdrawing group is in the close proximity. That electron density should be withdrawn by this electron withdrawing group. Then only CH bond cleavage will happen. Otherwise, it won't happen. Here, the CH bond is there, but it cannot be cleaved because it is a strong bond. So these are some fundamentals, and we can discuss what is Umbelong. Umbelong is a German word. The meaning is reversal of polarity or polarity inversion. So this concept also put forth by D. Seebeck and E. J. Corey. So we can look at what is Umbelong. Here the polarity is carbon polarity is positive, and due to the electronegativity of oxygen, the electron density will be pushed towards oxygen, and it will be del negative. And after reacting with the thiol, it will form a dithion, and after that it is possible to pick this proton with a strong base. So the carbon polarity in that center will be anion. So the reversal of polarity is happen. Here the carbon center is positive, same carbon center become negative. So this process is known as Umbelong. Another Umbelong we can see here in the case of Witting elite formation, triphenyl phosphine is attacking to the carbon positive center by a SN2 reaction, and a phosphonium ion formation is taking place, and it will push the electron from the CH bond, and then it is possible to pick that CH bond and make an anion. So this will result the elite formation. Another Umbelong is carbon is positive here, and del negative charge is given to the bromide, and in presence of magnesium and diethyl ether, it is forming organomagnesium halide. Then the carbon at center will be negative. So reversal of polarity happen. So whenever a Umbelong is there or reversal of polarity is happening, there is a chance to get the Nobel Prize. So you can also think of certain Umbelong reactions and you can turn to the research area having a handful of opportunities. You can grab CSIR Junior Research Fellowship in India and various other fellowships also there in order to nourish your research career. And you can also awarded a Nobel Prize in chemistry. So PhD chemistry, it will turn in mainly to the research field, and academia you can become a teacher. So many opportunities are together giving by taking a PhD in chemistry. So you can read certain books in order to prepare for CSIR NET JRF examination. So I can share this name of these books with you. So you can read these books and try to qualify the CSIR JRF examination and become a research fellow and try to get a Nobel Prize. So thank you for your kind attention.
താങ്ക് യു രഞ്ജീഷ്, താങ്ക് യു വെരി മച്ച് ഫോർ ദ ഇൻസ്പയറിംഗ് വേർഡ്സ്. ഇപ്പോ രഞ്ജീഷിനെ കുറിച്ച് രണ്ട് കാര്യങ്ങളോടെ ഞാൻ ഒന്ന് സൂചിപ്പിക്കാൻ ആണ് ഉദ്ദേശിക്കുന്നത്. കാരണം ഇത്രയും പറഞ്ഞുകൊണ്ട് മാത്രം നിർത്താൻ ഉദ്ദേശിക്കുന്നില്ല. കുട്ടികൾക്ക് എന്തെങ്കിലും ഡൗട്ടുകൾ, അതായത് ഓർഗാനിക് കെമിസ്ട്രി ആയിട്ട് ബന്ധപ്പെട്ട എന്തെങ്കിലും സംശയങ്ങൾ, പഠിക്കാൻ പാടാണെങ്കിൽ രഞ്ജീഷിനോട് ചോദിച്ചാൽ അതിന്റെ എളുപ്പ വഴികൾ രഞ്ജീഷ് പറഞ്ഞു തരുന്നതായിരിക്കും. കാരണം ഹി ഹാസ് ക്ലിയർഡ് CSIR നെറ്റ് 3 പ്രാവശ്യം ക്ലിയർ ചെയ്തിട്ടുണ്ട്. 2014 തന്നെ ജൂണിലും ഡിസംബറിലും ക്ലിയർ ചെയ്തു. അതുപോലെ തന്നെ 2015 ക്ലിയർ ചെയ്തു. ഗേറ്റ് എക്സാമിനേഷൻ 2015 ക്ലിയർ ചെയ്തു. അതിനോടൊപ്പം ചേർത്ത് പറയേണ്ട കാര്യം, ഞങ്ങൾ ഒരുമിച്ച് നെറ്റ് പഠിച്ചതാണ്, നെറ്റ് കോച്ചിങ്ങിന് പഠിച്ചാണ്. അതുകൂടാതെ എംഫിലും പഠിച്ചാണ്. എംഫിലിന്റെ സമയത്ത് തന്നെ രഞ്ജീഷ് ഒരു നെറ്റ് കോച്ചിങ് ഇൻസ്റ്റിറ്റ്യൂട്ട് തുടങ്ങുകയും ആ നെറ്റ് കോച്ചിങ് ഇൻസ്റ്റിറ്റ്യൂട്ടിന്റെ ആദ്യത്തെ പ്രാവശ്യം തന്നെ ഒരു 4-5 പേർക്ക് നെറ്റ് ക്ലിയർ ചെയ്യുകയും സാധിച്ചു. അപ്പൊ നിങ്ങൾക്ക് എല്ലാവർക്കും അറിയാം നെറ്റ് ക്ലിയർ ചെയ്യുക എത്ര പാടാന്നുള്ള കാര്യം അറിയാം. നെറ്റ് ക്ലിയർ ആക്കുക എന്ന് പറഞ്ഞാൽ അതിലും പാടാണ് ഉള്ള കാര്യമാണ്. അപ്പൊ 5 പേരോളം നെറ്റ് കോച്ചിങ് നെറ്റിൽ ക്ലിയർ ചെയ്തു ഒറ്റ പ്രാവശ്യം കൊണ്ട്. പിന്നെ അദ്ദേഹം PhDക്ക് വേണ്ടി നാഷണൽ കെമിക്കൽ ലബോറട്ടറിയിലേക്ക് പോവുകയും PhD തിരക്കിലാവുകയും ചെയ്തു. ഇപ്പൊ തിരിച്ചു വന്നിട്ട് നെറ്റിന്റെ കോച്ചിങ് ഒക്കെ ആയിട്ട് ബന്ധപ്പെട്ടും അടുത്ത പോസ്റ്റ് ഡോക്കിന് പോകേണ്ട കാര്യങ്ങളുമായിട്ടൊക്കെ ബന്ധപ്പെട്ട് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. അപ്പം കുട്ടികൾക്ക് എന്തെങ്കിലും ഓർഗാനിക് കെമിസ്ട്രി ആയിട്ട് ബന്ധപ്പെട്ട് എന്തെങ്കിലും ഡൗട്ടുകളോ കാര്യങ്ങളോ ഉണ്ടെങ്കിൽ നിങ്ങൾ ധൈര്യസമേതം കടന്നു വന്ന് ചോദിക്കേണ്ടതാണ്. ആർക്കെങ്കിലും എന്തെങ്കിലും ഡൗട്ടുകളോ വല്ലതും ഉണ്ടോ? പഠിക്കാനുള്ള എന്തെങ്കിലും എളുപ്പവഴികളോ അല്ലെങ്കിൽ എന്തെങ്കിലും വേണമെങ്കിൽ ജസ്റ്റ് ഒന്ന് ചോദിക്കുക. ഇപ്പൊ സെക്കൻഡ് ഇയേഴ്സ് പ്രത്യേകിച്ച് നിങ്ങൾ ഓർഗാനിക് കെമിസ്ട്രി പഠിക്കാൻ തുടങ്ങി, നിങ്ങളുടെ 3rd സെമ്മിലേക്ക് എത്തിയിരിക്കുകയാണ്. നിങ്ങൾക്ക് എന്തെങ്കിലും ഉണ്ടോ, ഡൗട്ടുകൾ കാര്യങ്ങൾ ചോദിക്കാനുണ്ടോ? ഡൗട്ടുകളൊന്നും ഇല്ലെന്ന് തോന്നുന്നു.
I think everybody convinced the talk.
Okay.
100%. If some queries are there, I am very much happy to answer. You can ask any question in the discussed part or undiscussed organic chemistry part. If you are facing some difficulty in order to understand certain portion, or you can discuss. Asking a question is a good indication. You listen the talk carefully, then only you can ask a question. Definitely numerous questions can be asked. So that is also a skill you should develop. A right question will be solving the problems. So the session is open to the questions. So if somebody has questions, you can directly ask.
ചോദിക്കാൻ മടിയാണെങ്കിൽ യു ക്യാൻ ടൈപ്പ് ഇൻ ദ ചാറ്റ് ബോക്സ്, അല്ലെങ്കിൽ എന്തെങ്കിലും പ്രോബ്ലംസ് ഉണ്ടെങ്കിൽ, ഓഡിയോ പ്രോബ്ലംസ് ഉണ്ടെങ്കിൽ ചാറ്റ് ബോക്സിൽ ടൈപ്പ് ചെയ്യാം. ആർക്കെങ്കിലും ഓക്കെ ഒന്നുമില്ലെന്ന് പ്രതീക്ഷിക്കാം. രഞ്ജീഷ്, ഇപ്പോ അടുത്തത് എൽസ.
Thank you, sir, for the informative webinar. Next, I would like to invite Sujit NS, Association Secretary, to deliver the vote of thanks.
സെന്റ് മേരീസ് കോളേജ് മണർകാട് പോസ്റ്റ് ഗ്രാജുവേറ്റ് ഡിപ്പാർട്ട്മെന്റ് ഓഫ് കെമിസ്ട്രിയുടെ ആഭിമുഖ്യത്തിൽ നടത്തിയ നോബൽ പ്രൈസ് ഇൻ ഓർഗാനിക് കെമിസ്ട്രി എന്ന വെബിനാറിൽ മുഖ്യ കർമ്മത്തെ വഹിച്ച നമ്മുടെ ഡിപ്പാർട്ട്മെന്റ് HOD ഷിബി മിസ്സിന് നന്ദി പറയുന്നു. ഓർഗാനിക് കെമിസ്ട്രി എന്ന വലിയ ഒരു ഘടകത്തെ വളരെ ഫലപ്രദമായ രീതിയിൽ നമുക്ക് വെബിനാർ എടുത്തു തന്ന ഡോക്ടർ രഞ്ജീഷ് KC സാറിനെയും കെമിസ്ട്രി ഡിപ്പാർട്ട്മെന്റ് വീട്ടിൽ നന്ദി അറിയിക്കുന്നു. ഞങ്ങളുടെ എല്ലാ പ്രോഗ്രാമിനും ഞങ്ങളോടൊപ്പം ഉണ്ടാവുന്ന ടോണി സാറിനും നന്ദി പറയുന്നു. അതോടൊപ്പം തന്നെ ഞങ്ങളുടെ ക്ലാസ് വാർഡൻ ജിലു മിസ്സിന് നന്ദി പറഞ്ഞുകൊണ്ട് ഈ പരിപാടിയിൽ സഹകരിച്ച എല്ലാ അധ്യാപകർക്കും വിദ്യാർത്ഥികൾക്കും നന്ദി പറയുന്നു. താങ്ക് യു.
Thank you for your acknowledgement.
Thank you everyone. Thank you.
Thank you.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
രഞ്ജീഷിനുള്ള താങ്ക്സ് ആട്ടോ. രഞ്ജീഷ്,
Okay, I am accepting. Thank you.